Hi, I'm Tom Ricord again. This is a continuing series of videos on plumbing. What we're going to talk about today are water heaters. Basically, there are several types of water heaters. Today we'll only talk about electric water heaters. A water heater is pretty much defined by the type of fuel that's used to heat the water. In this country, in the United States, we have gas, propane or natural gas, electric, which is from a power plant somewhere, solar, which of course is from the sun, and some other, perhaps oil-fired. But today we'll only talk about residential and light commercial individual water heaters, 30, 40, or 50 gallon. Specifically, we'll talk about electric water heaters. So all we're talking about today is electric water heaters, and what I'm going to show you is a 40 gallon, fairly new Whirlpool electric water heater. Alright, now if you're uncomfortable with electricity, don't do anything on this video. If you think you're going to get electrocuted, if you're uncomfortable with electricity, do not engage in any of these repairs. Alright. The first thing you need to know is that it has to have a power source. The power source for this water heater is electricity. Right here is a disconnect. You have 240 volts coming to your disconnect right here. And it's mandated by the new NEC, National Electrical Code, that you have a disconnect. Now I'm pulling up the top of the disconnect and I'm showing you right there how the wires come in to the disconnect. And I'm going to pull this. This terminates the electricity to the disconnect and of course to the water heater. So now you can safely work on this. Now let me pull the plate off and let me show you how it's wired. Alright, now anytime you're dealing with electricity, even though you saw me pull the disconnect, you always pull your meter out. Doesn't have to be like this, but any kind of a meter. And what you do is you test. You test your voltage leaving, going to the water heater to make sure that you have none. And you can see right here, see here on the nothing. And then you also take it to a ground. Right here is your ground. Make sure you have nothing on the ground. Alright, so nothing registered, so there's no electricity going to this water heater. This right here, it doesn't, I know that they're colored brown, but it really doesn't make any difference. Electricity doesn't know what color the wires are. You have 110 volt on this side, 110 volt on this side, and a ground right here. All that is inside conduit, as it should be, and it goes to this device right here. Now this, on the newer water heaters, this is what manufacturers have gone to. It's an energy smart system. And most water heaters in the past consist of a wire that goes to a thermostat right here and right here. And right here typically is just a box that allows the wire from the water heater to connect to the line voltage from the house. And that's typically what this has been used for. Now what we've got is and I've already took the liberty of disconnecting these screws, and I'm going to remove this so you can see what's inside here. Right, what we've got inside here, this is the wires that are coming from the disconnect, so it's safe to pull these apart. You've got voltage in is 220, and you can see the red wire, black wire, and it doesn't really matter what color the wires are, but you've got 240 volts coming into this. What you have here is a printed circuit board. Now the new water heaters, a lot of them have the printed circuit boards, and the reason that they have these is to enhance the energy saving capabilities that the water heater does have. And what this water heater does, it allows you to adjust the settings on it. On here you can actually, without having to remove this device here, allows you to turn down your temperature from 120, 150 down to 80 if you want to. Also, it has a green on device, lets you know the water heater is on. It also has a device which you can regulate on, it's called the operating mode. And it allows you to, if you're going on vacation, it allows you to drop it to the lowest setting, low energy, low temperature, and this, you also have a reset device, and you can see right here that this button, this red button ever should pop up. You can push it down and that resets this board. So in case there's an overage from the power company, you can go back to your water heater, and instead of calling an electrician or plumber to come out and readjust everything, you can adjust it yourself. Most electric water heaters, 240 volt, can have two heating elements. This one, like 90% of US water heaters that run on 240 volts, have a heating element at the top and one at the bottom. The heating element just consists of a long tube. It's a piece of wire, a rigid piece of wire that screws into, right there you can see it, this screws into the body of the tank. This wire and this wire emanate from that control panel on the very top. There's a printed circuit board that's constantly monitoring this heating element. When that heating element has been satisfied, it works in tandem, so that the first element that's satisfied is the bottom. You can see right here on the lower element, it operates in tandem with the upper element. You can see the wires are different colors. Electricity doesn't know that it's different colors. It's just for the purposes of the manufacturer and the technician to know that the colors of the wires. You can see that this blue is the same blue wire that goes to this one. And these elements, these heating elements, are a long piece of wire that's rigid that goes into the middle of the tank and comes back. You can actually unscrew this element if this element should fail, and that's one of the common failure items on water heaters, are the heating elements, which typically indicate to you that you may be running out of water, or you can't take a long shower, and that's because the heating element has failed. Of course, it's critically important that every water heater have a ground, and you can see typically a ground wire is green, as this is, and of course there's a green wire nut, a green screw to let you know that that's the purpose of this wire, is to be under that screw, and this water heater is properly grounded. Now that's the electrical portion, that's basically the basic electrical portion for this water heater. And this is a high-tech water heater, more so than you've ever seen them. They've become more high-tech with these increasing use of printed circuit boards, which really make it a lot easier to diagnose if you have a failure. One of the issues that you always should make sure with water heaters is that you have, and most of the time it comes standard, is a pressure relief valve. This is the pressure relief valve. This operates only when either temperature or pressure cause this valve to open. You can see that it's plumbed with a 3/4 discharge line. This 3/4 discharge line is the same line, same size line that comes into the tank. What the purpose of this is to prevent this water heater becoming a bomb in your house. When the water heaters were first developed in the early part of this century, they weren't fitted with pressure relief valves. And what happened were there were thousands, hundreds of thousands of failures of these water heaters, and they would literally blow up because the water, when this or that or this failed, in other words, the thermostat would fail in the open position, allowing water to keep coming, and there was no place for the water to go. It would just continue to heat and get hotter and hotter and hotter. As the water gets hot, it expands. At some point, it will expand so much that this tank will blow up. So we've got to give a place for the water to go, and it'll go. This is actuated, and you can, every month or so, you should probably pull this up and release water. And what that does is it lets you know that this is working properly. At least once a month, you probably should check this pressure relief valve. And by check, all you do is you open this valve up and you hear the water shooting out of here. Okay, that lets you know that this pressure relief valve is doing what it should be doing. This valve, again, opens at 150 psi or 210 degrees, whichever it comes first. So you want this valve open. This valve is going to open at 150 psi. That's 150 pounds per square inch, or 210 degrees. So if this ever gets to be 210 degrees, or the pressure exceeds 150 pounds per square inch, it'll open up, and the water coming in, water will still come in. This tank will cool down, and nothing will blow up. Now that covers the pressure relief valve. Also on these water heaters, they're plumbed with 3/4 inch intake. It doesn't matter if it's PVC, copper, or plastic like this. But everyone should have a on and off. You should have a means of disconnecting the water. So in case you ever had a leak or whatever you needed to do, that you could shut the water supply off. And that's what this is. This is a water shutoff, so that we can terminate the water coming into the tank should it ever be necessary. Now on the bottom, you see, you've also got a means that we can drain the water heater. This is important. At least on a monthly basis, you want to hook up a hose to the bottom of the tank, open this up, and let the water run out into your yard or into the street or whatever. The purpose of that is there's sediment that builds up. The water gets dirty, tanks, the heating elements break down. You can clean your tank somewhat by getting out the sediment that sits on the bottom, and it's a very inexpensive way of maintaining your water heater. Another interesting thing that happen with water heaters, because electricity runs through them constantly, is that the tank gets eaten up. Back in the old days, when they made lots of water heaters, the tanks would disintegrate in a year. And so what they did was that they put anodes in there. And these anodes were pieces of zinc. In this one, this came out of a water heater that was several years old. This screws into the middle of the water heater. It's in this right here. There, you can see this little screw. This anode is a sacrificial anode, much like that you have on the bow of the ships. Because just like a ship, when this metal passes through water, it creates a mild electrical current. That electrical current eats away at anything metal. This zinc is sacrificing itself for the integrity of this tank. So as this electricity passes through this tank and heats the water up for our benefit, it also is eating away at the steel on the tank. So instead of eating the steel on the tank, we wanted to eat the zinc on this piece of zinc that we screwed in the middle of the tank. And you can see what it's done over the years. This has been eaten away very severely. You can see this should be round and shiny, just like this piece right here. Like when it originally came into being, originally installed, it was bright and shiny like this. And after a few years, it's all pitted, has several holes in it. And this also has a bearing on how bad your water will smell periodically. So if you're ever concerned about that, one of the things you should do, of course, is shut the water supply off and remove your anode rod and put a new anode rod in, screw it in. It's just screwed in. It's 5-sided nut. You screw it out and screw one back in, and you will increase the life of your tank, because if this thing disappears on you, that means you no longer have a sacrificial anode. Without a sacrificial anode, the tank is open to being eaten away by the electricity that runs through the tank. The other thing that you need to be aware of, there's a dip tube that is in all these tanks. That dip tube, when the water comes in, it goes to the bottom of the tank. It's a piece of plastic that runs inside the tank and goes to the bottom here. If you're ever running out of water, out of hot water, and you want to know why, check the dip tube. That dip tube, as the water comes in, make sure that it's solid. Basically, you unscrew your intake, you pull this screw up, and make sure that you've got your dip tube runs from here to about here in the tank. That way you make sure your water heater is working properly. That's it. If you have any questions, give us a call at etservices.biz and we'll be happy to answer.